Welcome to the JEE Main 2026 Varava series. So in this series, I am going to teach all the topics which are related to the JEE Main maths, okay, starting from sets. So today, let us observe the sets, okay. What about sets? So in that sets, you see, the first topic is our sets. You see, sets, set theory. So before going to the set, in daily life, we can observe the groups, okay, or a collection of objects in real life, right? Like set of books, set of group of students, okay, a list of states, a list of countries, okay, collection of songs, collection of mobiles, can I say, okay? So like this, we can observe all the things, okay? By observing all the things, if I specify the word, the main word that is distinct or this distinct comes into the picture, then it is going to be a set. How it is a set? Let us observe the collection of well-defined objects. So we know we are collecting all the objects, right? If I say set of books, so it may be mathematics, physics, or of different classes or same classes. I can say like that. Okay, right? Very good. And now you see, I am telling about like if in order to define a set, it is a collection of objects of any kind. That is the meaning. But here, one important thing, which are distinct and which are distinguishable. You should not take the same. Okay. Suppose you take maths JEE main book. So you should not repeat that. Okay. You have to go with some other author or something like that. Okay. Yes. So here, well-defined objects clearly defines if the object belong to a given collection or not. That is also very important. Whatever the object you are taking, suppose I am taking some books, okay? In that group, say this is my group, okay? This is my group. I have books like math, physics, and chemistry. Suppose if I say about social book is not belonging to that group, correct? Okay. So first let us check whether the object, this social is one of the object of this group, okay? Not this group, I mean different objects, okay? I am taking social is one of the object which does not belong to the group. Then we cannot define this object in this group. You understand? Very good. So the objects of the collection, the whatever the objects you are collecting, those are called elements. What are those called? Elements or members of the sets. Okay, or members of the sets. So sets can be denoted by the letters, capital letters. Okay, like A, B, C, D, like that, capital letters, alphabetical order. Okay, like A to Z letters. You can use any letter. So I am taking A is equal to 1, 2, 3, 4, so on. You see, these are all what kind of numbers? Very good, natural numbers, right? Right. So here the objects are 1, 2, 3, 4, so on. Okay. Those are called elements. What are those called? Elements. Okay. Here, how do we define a set? Well-defined object clearly defines a set. Well-defined collection of objects is called a set, and the objects which are present in that collection are called elements. Okay, elements, and or these are also called members of the set. Okay, right. So set is represented by the capital letters. Understand? Yeah. So now we can observe here they gave some example. You see, you can observe this example. Odd natural numbers less than 10. What are the odd natural numbers which are less than 10? 1, 3, 5, 7, 9. Okay. Set is represented like this. This set already denoted with a capital letter, I said. Okay. And these two can be represented or can be whatever the members which are present in the set. Those can be in between two braces. two flower brackets, I can say. Okay, like this you have to represent the set. You see, numbers less than 10. Less than 10, those are all odd numbers. Can I represent like this? Right. So is it well-defined set or not? Yeah, because you take an odd number which is less than 10, particularly they are saying rivers of India. Okay, rivers of India. So what are the rivers of India? You can write different rivers of India, right? So let me take rivers, Krishna, Godavari, okay, and Kaveri, Penna, like this. So many rivers we can write, okay? And vowels in alphabet, okay? Vowels, C is equal to A, E, I, O, U, like this, okay? Vowels in alphabet. These are also different, right? Those may not repeat. Here also different types of rivers means Krishna, Godavari, Kaveri, okay, and Penna, like this we are writing, not repeating, okay, yes, and also those may not same, okay, collection of bright students. Look at the next part. So these are well defined. We observed these three examples. Now you take one more example, collection of tall students in your class. What I'm saying, tall students in your class. So is it possible to say that tallness is this much? No, right? So beautiful girls in of the world, you see, beautiful girls of the world. So there is no perfect identification, right? So because of that, these cannot be not well defined collection. Okay, so these are not sets, I can say. What is the first one? Bright students in your class. Okay, you take bright students because those are also, we cannot particularly say that yes, this is the bright, like that you cannot say. And collection of renowned mathematicians of the world. So many mathematicians in the world, renowned, we can't say. Beautiful girls of the world, collection of fat people, collection of tall people, collection of short people. All these are not well-defined sets. Okay, no, not well-defined collections. So these are not sets. Okay, whereas these are sets. You understand? Why? Because these are well-defined collection. These are not well-defined collection. Understand? Very good. Let us go to the next part. The terms, objects, elements, and members of a set are synonymous, right? Elements, members, or objects, all are same. Okay. Sets are generally denoted by capital letters. We already know. The elements of the sets are separated by the small commas, like small letters or comma. Small letters followed by commas. Okay. Elements. If A is an element in a set, we can say that A belongs to A. Say, let A is equal to A, B, C, D, I am taking. Okay. Now, I want to say A, this element belongs to this set or not. Yeah, how do you write? A belongs to, this is the belongs to symbol. A belongs to A. Okay, like this we are going to write. Or you can take D belongs to A. Okay. Or suppose E, is it any E element present? No. E does not belong to A. Like that we can write. Okay. If B is not an element of set, does not belong to A. Okay. Understand? Yes. So like this, we have to say the elements whether they are belonging to the set or not. Okay. Right. Now, if you see normal numbers, categorize the numbers, you can see set of natural numbers, set of whole numbers, set of integers, rational numbers, irrational numbers, real numbers, and set of complex numbers, right? So set of and inside and one more you can write here under the integer set. Can I write it as set of positive integers? Yes, the set of positive integers. Okay, z plus I can write. Okay, and set of positive rational numbers, that is q plus. Okay, next set of positive real numbers I can write set of r plus. Okay, like this we have different types of sets: natural numbers, whole numbers, integers, and rational numbers, and irrational numbers, qc. irrational numbers, real numbers, and the final one is complex numbers. Okay, what are those? Complex numbers, right? So the order in which the element of a set is written immaterial. Say I am taking my set. A is equal to 2, 3, 4. Okay. But what are the elements present in this? Who are the members? 2, 3, and 4. I can write this as 4, 3, 2. Yeah. It is also the same set we can represent. And A is equal to 3, 4, 2. You can write. Okay. Order is not important. Order is not immaterial. Okay. Order is, you can write the elements in any order, but elements cannot be repeated. Okay, elements must be distinct. Okay, distinct or distinguishable. Okay, understand? Yes. The next, how to represent a set? I want to represent the set. Okay, there are different types of types to represent the set. First one is roster or tabular form. Okay, in this method, generally, those are in the roster form, all the elements of a set are enclosed within braces. Enclosed within braces. Generally, we will write the set form means this form only. Okay, roster form. 1, 2, 3, 4. And braces, brace close. Okay, like this we are going to represent. Understand? And each element is separated by a comma. You see, there is a comma between element, each and every element. The few examples, the set of even positive numbers. Even positive numbers. Even positive numbers means 2, 4, 6, less than 7 they said. Only 7, 8 is not coming because less than 7 they said. Set of odd natural numbers is represented by 1, 3, 5, right? Or natural numbers. The 3 dots ellipses denote the list of endless, right? If I keep 3 dots like this, 1, 3, 5, so on. So what is the meaning? It is endless. Okay. In the roster form, the elements of a set are not repeated. In the roster form, the elements cannot be repeated. For the set itself, you cannot repeat the elements. Okay. All the elements are taken as distinct. All the elements can be taken as distinct. Here, let us take SCHOOL. Okay, this is school. This, I want to write this in set form or roster form. How can I write? SCHOOL. Yes or no? Why? Because here it contains 2 elements, same. So we should not consider the 2 elements. You must take only single element. You understand? Very good. Yes. Now let us observe the order in which the element of a set is written is immaterial. Okay. So order, you can take any kind of order. So you understand the roster form or tabular form? Just separated by commas. The elements are going to separate by a comma within the braces. You understand? Very good. Next. You see, the other one is set builder form. First one is roster form and the next one is set builder form. In this set builder form, you see, you can observe in this set builder form mainly, it is going to be a general thing, generalized one. Okay. So here, the element is generalized as a variable. How it is going to be generalized? It as a some variable. Okay, element is generalized as a variable x, and then after that colon, okay, colon or a vertical line at the property which defines each element of the set can be written in the form like this. You see, you can observe it in the set builder form. All the elements of a set possess what kind of property? Common property. Okay. Set builder form, all elements possess a common property. This common property does not match with any element outside this set. Okay. You see now, set of vowels here. Vowels means X such that, so one element is X, which is present in the vowel set. How is it? X such that, or X colon, X is a vowel. You understand? X is a vowel in English alphabet. Okay. So this is going to be the first X braces set of all. Okay, braces set of all. Set any other also can use. Any other also can use, right? X means any other one number. And colon such that, and property possessed by element of a set. So set of all X such that X is a vowel in English alphabet. What they gave? X such that all vowels in an English alphabet. X such that X is a natural number. The same thing. Here we have written the question. X is the natural number and 3 less than X less than 10. Suppose between 3 and 10, this X is going to lie. Okay. Yes. So set of all X such that X is natural and X lies between 3 and 10. Okay. Hence the numbers are, what are the numbers you are getting? Between 3 and 10. 4, 5, 6, 7, 8 and 9. Okay. Understand? Like this. Okay. So this is the set builder form. Set builder form is particularly a generalized form. By taking variable, we are going to mention it. Understand? So two types of representation. One is roster form. The other one is set builder form. Okay. Set builder form is in this generalized, we generalize the things. Got it? Yes. Next. Next, you can observe. So set builder form, this one, the property possessed by the element of a set, colon, symbol, and then set of any other followed by braces. Okay, right. Next, you see subset. Very important point, subset. You see, a set A is a subset of B if B has all elements of set A. Let me take one example. A is 1, 2, 3, 4. Okay. B contains, let me take 1, 2, 3. So this is the bigger set, right? So this is only some elements of A are present in B. Okay. So B is called subset of A. A is called superset of B. You understand? Superset and subset. B is called subset of A. Okay. And A is called superset of B. You understand? All the sometimes all the elements also B contains, even though B contains all the elements. Yeah, no doubt this is also a subset to this A set. Every set is subset to itself. That is very important. What is that? Every set is subset to itself. Every set is subset to itself. Okay. And then the next one is number of subset. You see, number of subset. Yes. Now, so how do you find the number of subsets? Say A is, how do you, first let me tell you how to write the A is subset of B. So this is my A. So this is subset symbol, subset of B. Here A is subset are equal to B, no? Because of this, I am going to write A is equal to 1, 2, 3. Not in this case. If you take the first case and the last case, A is subset are equal to B. Can I say? Okay. A is subset or equal to B. And you see, A is subset of B, A is subset or equal to B means what? X belongs to A and the small x also belongs to, which implies X belongs to B, right? Yes. Okay. Yes. So if you say if A is subset or equal to B, in the same manner, you see B is subset or equal to A. Then what do you say from this? Yeah, A is equal to B. So when both sets are subset and equal to each other, when A is subset or equal to B is subset or equal to A, then A is equal to B. Understand? This is about subset. Okay. So subset. Next, you see number of subsets. If set X contains X1, X2, X3, so on, Xn. So how many elements it contains? N elements, right? So n elements. If it contains n elements, X is equal to, in this case, you see, X1, X2, X3, so on, Xn. Okay. These are the elements contained by our X. So how many elements? There are n elements. Okay. N elements contained by the set, our big set X. Okay. So I want to write subsets. If you go on writing all subsets, it is to be found like 2 power n. Okay. So if X contains n number of elements, then number of subsets are 2 power n. You understand? Yes. Next, if you see the main properties of a subset, what are the properties of a subset? First, let us observe. Every set is subset to itself. Say, I am taking A is equal to 1, 2, 3. So this is no doubt subset to itself because at least one element should be present in A, that at least one element of A should present in B. Then you can say that B is subset of A, right? B is subset of A. If it contains more than elements or all the elements, right? Okay. That means every set is its own subset. That is, every set is subset to itself. Next, you take, I am taking, this is the set. This is my set. Can I call this as a set? Yeah, definitely. Why? Because there are no elements present in the set. Okay. There are no elements present in the set. So can I say that it can be empty? Yeah. This is going to be empty set. Very good. Empty set. Empty set is subset to every set. Empty set is subset to every set. Okay. And one more important point. So what is the first one? A set is, every set is subset to itself. Empty set is subset to every set. And the last one is, I am taking, I have A, B, C, 3 sets. Okay. What are my sets? A is subset or equal to B. Like this, I have all the sets. B is subset or equal to C. Then what do you say? We know that when A is equal to B is equal to C, then A is equal to C. The same thing will be satisfied in the case of sets also. Okay. That is, A is subset or equal to B is subset or equal to C, A is subset or equal to C. Got it? Very good. Yes. So you see, 1 minute. Set builder form, subset, done. Okay. Next, types of subsets. You see, if you observe, one is subset of, if A is equal to 1, 2, 3 and B is equal to 2 and C is equal to 2, 3. Okay. So what are the subsets? I am writing all the subsets to this. And B is subset to A, C is subset to A, and D is also subset to A. Am I right? D is also subset to A. And empty set is also subset to A, right? Okay. Right. So you see, if A is said to be proper subset to A, B, sorry. If A is said to be proper subset of B, A is subset of B, A should be subset of B, and A proper subset. When do you say that proper subset? If it not contains exactly the same elements in the others. Okay. You see, is it proper subset or not? Yeah. Is it proper subset or not? But this is not proper subset. Yes or no? This is not proper subset because what is the proper subset definition? A is said to be proper subset of B If A is a subset of B and A not equal to B, A never be B. A is not equal to B. A is subset of B and A not equal to B, then that set can be called as proper subset. Okay, got it? Proper subset. Understand? Very good. Let us observe. So normal subset means A is subset of B. Okay, A is subset of B. Next, super subset. Superset. What is meant by subset we observed? I already told you. A is equal to 1, 2, 3. B is equal to 2, 3. In this case, what I said, A is no, B is subset of A. A is equal to 1, 2, 3. B is equal to 1 minute. What I have taken before examples, let me check. 1 minute. You see, we have taken here in before case, you can see B is subset of A. Sorry, B is subset of A, right? B is subset of A. A is superset of B. Okay. A is superset of B. B is subset of A. C is subset of B. So these are all subsets of A. You understand? These are all subsets of A. Subsets of A are B, C, D, all. Okay. B is subset of A. B is subset of A and A is not equal to B, then it can be called as proper subset. Okay. Very good. And before also, okay. Next, you see, so proper subset you got? Yes. Super subset and subset, both we observe clearly. A is subset of B. Say, let me take A is subset of B means, I can take A is equal to 1, 2, 3. Sorry. A is equal to 1, 2, 3. Okay. B is equal to 1, 2, 3, 4, 5, 6. Let me take like this. Now, what do you say? Here, then A is subset of B, right? Here, A is subset of B. Very good. And B is it B subset of A? No, B is superset of A. Okay, this is subset and this is superset. Just opposite to that, you have to use the symbol. This is the symbol like this, subset symbol. Okay, got it? Yes. So types of subsets. Here you see total number of subsets means 2 power n. You understand? Total number of subsets. But we already observed the definition of proper subset, right? I want to know proper subsets. Okay. So total number of proper subsets. Suppose x is equal to, let us take x is equal to x1, x2, x3, x3, so on xn. Okay. I want to find proper subsets. How many proper subsets are existing for this? So total number of proper subsets means, how do you calculate? We know total number of sets. We already observed that total number of sets are nothing but 2 power n. You know that. Proper subset means only one element is going to be less, right? Excluding itself. Okay. So 2 power n minus 1 gives the proper subset. Okay. Total number of subsets is 2 power n. So proper subsets is equal to 2 power n minus 1. If you exclude itself, then it is going to be a proper subset from the total subsets. Okay. So if you take the statement A is subset of B, can be written as B is superset of A, then B can be called as superset of A. Okay. A is subset of B. Understand? Very good. So these are the types of proper subsets and normal total subsets, how to find, and total proper subsets, how do we find? Okay. Very good. Next, let us observe the types of sets. There are different types of sets. I already told you that if any set which contains no elements, empty, okay, that can be called as empty set, null set, you can say. Okay. A few examples. Set of odd numbers divisible by 2. Odd numbers which are divisible by 2, they are saying. What is the definition of odd number or even number? All even number, if you take any even number, that should be divisible by 2. Yes or no? But they are asking about odd number. Any odd number you take, is it possible to divide with 2? Completely divisor? Is it divisible? No. You are getting the remainder as, right? So if you divide any odd number by 2, you are getting the remainder as 1. Whereas if you divide the even number, if you divide the even number by 2, you are getting the remainder as 0. Okay. So all odd even numbers are divisible by 2. But, okay, set of odd numbers divisible by 2 is a null set, I can say. No odd number is divisible by 2. No odd number is divisible by 2. So that is empty set, I can say. Okay. Resultant set is a empty set. Next, set of even prime numbers is not a null set. Why? You take set of even prime numbers. Even prime. You know, prime numbers start with 2. Okay, 2, 3, 5, 7, 11, so on. So even prime, you have one thing. So it is not empty. Understand? A set of even primes not a null set. Okay, because 2 is a prime number and which is divisible by 2. Okay. Next, y colon y is a point of common to any two parallel lines is a null set, because what they said, these are the two parallel lines. Okay. What they said, any common point between two parallel lines. Parallel lines means they do not intersect. Whenever they intersect, you are getting a common point P, right? You are getting a common point because they are not intersecting. They are going like this. So do we get any intersection point or common point? No. So parallel lines cannot have any kind of common point. Okay, got it? Yes, very good. Next, this is about null set or empty set. Let us move to the next question. Next set. Any set is finite. Finite number of elements. You see, any set, you say, take this oval set, number of ovals which are present in this set, AEIOU. This is finite, right? Number of months. Any set is said to be a finite set if finite number of elements are present. Okay. January to 5th December or Monday to Saturday, right? So those are, what do you call, finite sets. Now, next, infinite set. Some are having men living presently in different parts of the world is non-countable, right? It is an infinite set, I can say. X such that X belongs to R. X belongs to R means you can take any value, real number set. Okay, you understand? X colon, X lies between 2 and 3. X belongs to R, infinite set. Why infinite? X lies between 2 and 3. So you can have more number of any kind of rational numbers. Between two rational numbers, there exists infinite rational number. That's why it is infinite set. You got it? Infinite rational numbers. This is going to be a infinite set. Equal and equivalent sets. Next. Any two sets, A and B, are said to be equal sets if all the elements of a set, A are in B and vice versa. Two sets A. When do you say that the two sets are equal? That is, the number of elements, each element of set A is same as that of the set element B. Okay, but the order may differ. Okay, but whatever the number of elements in set A is same as that of set B, and the elements also should be same element. Okay, then you can say that equal sets. Any two sets are said to be equivalent sets. Next, what? Equivalent sets. What are equivalent sets? Okay, you see, equivalent sets. Equivalent sets, you can see, equivalent sets in their number of elements in both the sets are same. Only number of elements. Say I am taking A is equal to 1, 2, 3. B is equal to 2, 3, 4. Okay, you observe now. So do they equal? No. Here 3 elements. Here also 3 elements. But the elements which are differed from A, right? When you check the elements in B, these elements, B elements are differ from A, right? Because, so those two are not equal sets. Am I right? Not equal sets, but these two are equivalent sets. These two are equivalent sets. Equivalent means the number of elements. How many elements are present in A? 3. How many elements are present in B? Whatever may be the element. Don't bother about the elements. 3. So, number of elements which are present in the two sets is same. That's why those are called equivalent sets. Equal sets means the number and as well as same elements should present. Understand? The number of elements in any set is said to be cardinal number. What is that? Say A is equal to 1, 2, 3, I said. Then how do you represent the number of elements? Number of elements in set A. This is called cardinal number of set A. Okay, cardinal number of set A, which is equal to 3. I can write 1, 2, 3, 3 elements, no? Okay, yes. Suppose in this A, E, I, O, U, how many are there? 5 elements. So N of B is equal to 5, you can write. Understand? Any set does not change if one or more elements of the set repeated. June, November, April, September. Those are equal. Got it? Yes. Next. You see the next set. That is what? Singleton set. Singleton. The name itself says it contains only a single element. N of x, number of elements in the set x is equal to only 1. X is equal to 2. This is a singleton set. Okay. You see, for example, x colon x belongs to n. X lies between 1 and 3. X belongs to n. Natural number set. What are the elements in the set x? It's only 2, I can say, right? So it is singleton set between 1 and 3. Okay, that is only 2. Set of null set. That is set null set. X such that x belongs to n. Between x, this, that is set between 1 and 3. 1 minute. You see, the x lies between 1 and 3. X lies between 1 and 3. That is only 2. Okay. So set phi. Phi is a set containing alphabet 5. Okay. Phi. Set containing alphabet 5. Now you see, this is a null set. Whenever you have like this is a null set. Okay. Got it? Let us observe the next thing. Universal set. Next set is universal set. What is universal set? It is a set in which it includes all the sets under consideration. Okay. It is a superset of each of the given sets. What is that? It is a superset of the each given set. Thus, a set contains all sets in a given context called universal set. Okay. You see, you can observe this. A is equal to 1, 2, 3. B is equal to 2, 4, 5, 6. If I find A union B, union, okay, union means mixing all the things together for these two elements. For these two sets, sorry. 1, 2, 3, union, 2, 4, 5, 6. Okay. So how do you write then? 1, 2, 3, 4, 5, 6. That's it. Understand? A union B. Like this we are going to do. Yes. is a universal set which contain all elements of sets A, B, and C. Okay, that is called universal set. It is represented with the U. A union B, like this you have to write between A and B. Understand? Next, disjoint set. Next, disjoint. The name itself says that means A and B. There are no common elements present in between A and B. There are no common elements. That means empty set. That's why A intersection B is equal to 5. Intersection means common. Union means together, all mixing. You understand? Intersection means common. If you take A intersection B is equal to 5, that means when you take any two sets, their intersection part is going to be 5. Okay? Then the two sets are said to be disjoint sets. Suppose A intersection B is not equal to 5. Not equal to 5. Then those may intersect and they overlap. You see, these two are not intersect. Why? A intersection B, is there any intersection part? No intersection and no common part. Okay? A is equal to A and BC. BC intersecting sets. Set of even natural numbers, set of odd natural numbers of disjoint. Okay? Like this, we can write many disjoint sets. Understand? Disjoint means they cannot join. That means they don't have any intersection point. That is the meaning. Okay? Right. Next, complementary set. Complementary set A is set containing all those elements of universal except all those elements they are present except the element in set A. Except the element in set A. Okay? Except the elements in set A. Got it? Universal set. Universal set means we already observed that universal set and then disjoint set also done. Okay. And next complementary set. In this complementary set is a complementary set of A is a set containing all those elements of universal except the element in the set A. It is denoted by A complementary. A complementary. Say it belongs to all sets. Okay. Suppose A is equal to 1, 2, 3, 4, so on up to 50. This is universal set. Okay. Universal set I am taking. A is equal to 1, 2, 3, 4, 5. 1, 2, 3, 4. Let me take. Then A complement means just you exclude the elements which are present in A, and whatever the elements which are present from 5 to all the elements 50, that is A complement. A complement or A complement, you can write like this also. So all disjoint sets are not complementary sets. All disjoint sets are not complementary sets. This is very important. You understand? Next, power of a set. Power set. The collection of all subsets of a set A is called the power set. Collection of all subsets of set A is called the power set. So it is denoted by P of A. Okay. So P of A, P of X is equal to 2 power N. N of P of X is 2 power N. 2 power N. What is power of a set? The power of a set can be 2 power N. Okay. Why? The collection of all subsets of A is called power set of A. Collection of all subsets. P of A. Okay. P of A is equal to X such that X is a subset of A. If it has xn elements, then P of X is equal to 2 power N. N of P of X is equal to 2 power 2n. Okay. 2 power n. Sorry. 2 power n. Got it? Yes, very good. Let us observe this is about power set. Next, so these are the different types of sets. Okay, union of a set, and one more I forgot to say, intersection of a set. Okay, intersection. Let me write that. Intersection of a set. Intersection set. Intersection means if you have two sets like this, any common elements which are present in the two sets, that part can be called as intersection of two sets. Intersection of two sets. Okay. Next, you go to the Venn diagrams. So Venn diagrams, you can see the Venn diagrams. When John Venn discovered the Venn diagrams, like these are mainly usually a rectangle like this. Okay, this is a rectangle like this thing we are going to represent. This is going to be you here. You can observe universal set. Okay, and then you, in order to represent any kind of sets, this should be written inside this rectangle. U is represented by a circle inside the rectangle. Set A is subset of B. You see, set A is subset of, this is subset. This is a big set. Set A is subset of B. Yes or no? Because in B, A is present. Hmm? Right. A is drawn inside the circle representing B. A and B are not equal, but they have common elements. Then it represents A and B by two intersecting circles. Okay. Okay. Understand? Next, how do you represent diagrammatically A complement? Okay. Say this is my rectangle, right? In order to represent any kind of thing in Venn diagram, you need rectangle, that is universal set, A complement. So no doubt this is going to be A complement means like this. A complement. You can write like this. A complement. Understand? So A complement. In this manner, you are going to write. Okay. Right. So complement of a set. This is the complement of a set. How to write the complement of a set, and also Venn diagrams. So in Venn diagrams, union first you have to take, and then the remaining sets can be taken. Okay. Very good. Next, union of sets, set operations. So these are the main set operations, union and intersection. Listen carefully. A and B are two sets, then union of A and B of the two sets. Set of all elements belong to set A and B. It belongs to set A and set B. It is also defined as A union B is equal to X colon X, such that X colon X belongs to A or X belongs to B. What is that? A union B. Union means or. Union means what? Or. Okay. Similarly, let us go with intersection. Intersection. In intersection of sets. Next one. Say, you see, intersection of sets. Universal set we observed. Okay. Universal set we observed. Next, you see, Venn diagrams done, set operations, intersection of sets. Okay. Come on, you observe now. Intersection of sets. In intersection of sets, you take intersection of sets. So the intersection of sets My slideshow is not working. Slideshow. Okay. You see, Venn diagrams, it is done, and then union of set, intersection of sets. Okay. Intersection of sets. A and B are two sets. Intersection. A is one set and B is another set. Let me take. This is my universal set. Okay. This is my universal set. I am taking A is one set and B is another set. Okay. A and B are the two sets which are in universal set. Okay. So you take intersection means the common, both common part. This is common part, can we call like, okay? So this is called intersection of sets. Suppose I gave A is equal to 1, 2, 3. Oral question I am giving. B is equal to 2, 3. 2, 3, 4. If I ask A union B, how do you find? Yeah, so simple. A, you are writing, union B, you are writing, and you are writing all the elements without repetition, right? Okay. All the elements without repetition. When I ask for A intersection B, what do you write? Common elements in both A and B. Okay. What are those? Only 2, 3 you are writing. Understand? So I want to represent the Venn diagram intersection part, A intersection B. So A intersection B is going to be represented like this. This is my A intersection B part. Okay, this part. You understand? Whereas if I go with A union B, okay, if I go with A union B, what I will get? Let me observe now. You see, this is my universal set. This is A and this is B. Okay, A and B. So what do you represent? A total you have to represent, and B total you have to represent, and both part also. So how do you represent? In this way, you can represent the A union B. You understand? Very good. Let us go with the next one. You can see. So intersection part like this, we are going to represent. Okay. And next, you see. Yes, you see the next one. Union of sets, it is done. Intersection of sets, it is done. Next, difference of sets. What is that? Next one, difference of sets. And let us observe the difference of sets. A and B are two sets, then the difference of A and B is the set of elements which belong to A or not, and the set elements which belong to A and not B. A but not B. The elements, that is A minus B. What is the meaning of A minus B? Means the elements which belong to A only, but it does not belong to B. Suppose I am taking the sets, two sets like this. This is my A set and this is my B set. It should not connect with B. You should not include B. You should not touch B. Only A part can be taken. That can be called as, this is not there, sorry. Let me erase it. Yeah. You see, only this part. This part is called A minus B. Can I call this as A minus B? Very good. In the same manner, how can I represent with B minus A? Come on, let us write the B minus A. B only. There should not be any contact with A. This is B minus A. You understand? Like this, we can represent. So A minus B is not equal to B minus A. Okay. A minus B is not equal to B minus A. How do I write the set builder form of A minus B. Let me write. A minus B is equal to, what is the meaning? X such that X belongs to A and X does not belong to B. Okay. X belong to A and X does not belong to B. This is called difference of two sets. You understand? Difference of two sets. Yes. Let us go to the next set. Symmetric difference. This is different topic. Okay. This is very, very important. Symmetric difference of two sets. The symmetric difference, we observe the difference of two sets, A minus B, B minus A, like that. Okay. A symmetric means same. A symmetric, meaning symmetric difference of two sets is denoted by A delta B. What is that? A delta B. What is A delta B? A delta B is equal to A minus B union B minus A. Okay. A minus B. Suppose I am taking A is equal to 1, 2, 3, 4. B is equal to 1, 2. Okay. Now A minus B. Only the number of elements which are present in set A. It should not include B. 1, 2 are present. So I have to remove 1, 2. Only 3, 4 are present, right? 3, 4 is my A minus B set. Union B minus A in the same manner. So B minus A, because this is not possible in this case. So A minus B and B minus A union you take, you are getting A delta B. Okay. Like that you can get it. Okay. A minus B union B minus A. If you do, you are getting symmetric difference. Understand? What is A delta B? This is very important. A minus B union B minus A. Got it? Suppose I want to say next number of elements in different sets. Right. So before going to this, I want to concentrate on complementary set. Complementary set. Whenever you want to find complementary set, you should know one union, universal set. What is that? Universal set. Suppose A is universal set is 1, 2, 3, 4, 5, 6, so on up to 10. Let me take. A is equal to 1, 3, 5, 7, 9. Let me take like that. So I want to find A complement. How do you find? A complement is union of the set minus universal set minus A set of elements in A. That gives the complement set. That is, A complement is equal to mu minus A. Mu also we can call universal set. What is that? Mu. Okay, understand? So here I am finding 1, 2, 3, 4 up to 10 minus 1, 3, 5, 7, 9. If I erase 1, 3, 5, 7, 9 here, 2, 4, 6, 8, 10, right? These are left here. So this will be our A minus B. You understand? Very good. Next, you see number of elements. Number of elements in different sets. Yeah, number of elements in different sets. That is N of A union B. What I said, cardinal number I said. If A is equal to what I said, if A is equal to 1, 2, 3, 4, then the number of elements in set A are 4, right? Number of elements in set A is 4. That means N of A is equal to 4, we can say. Okay, understand? So N of A, N of B, okay, and N of A intersection B and N of A union B. If you relate all these 4 quantities, then you will get in this manner. N of A union B, what is that? N of A union B, that is N of A union B is equal to N of A, N of A union B is equal to N of A plus N of B minus N of A intersection B. Okay, got it? Very good. In the same manner, you see N of A union B. N of A union B, if A and B are disjoint sets, okay? If A and B are disjoint, then you are getting N of A union B is equal to N of A union B is equal to N of A plus N of B, right? N of A plus N of B, okay? N of A plus N of B, like this. And N of A minus B, that is N of A. So you see, we observed already. Let me tell you about this clearly. You take, this is our rectangle, okay? In this, we have taken one circle, N of A. N of A minus B, you have to observe, no? Right, N of A minus B, I want to observe. So these are my two circles. This is A and this is B, okay? N of A, this is total set. Let me write the first N of A with one color. Let me take N of A, okay? So with N of A, I am writing, I am drawing N of A. Let me write that. You take, this is my N of A, I am writing. N of A, okay? This is my N of A, okay? Yes, N of A is yellow, okay? Very good. And now what I am taking, the next one is N of A intersection B. I am taking with pink. A intersection B means which part? This is the part, pink part, okay? What I do? N of A total, sorry, N of A total, no, I have to draw. Sorry, I'm so sorry. N of A total, I have to draw, okay? This is my total N of A. From this total, I have to subtract N of A intersection B. Can I get N of A only? What is that? Let me draw on that. What is N of A? I am drawing. Look here with white color. This is my N of A. Oh, sorry, I took smart pen. Sorry. You see, I am drawing now. What I am drawing? N of A. Just I removed from N of A. I removed N of A intersection B. Can I get N of A minus B? Very good. Okay. Like this, we are getting N of A minus B. You understand? Yes. Next, N of A delta B. N of A minus B, in this manner we are getting. Next, N of A delta B is equal to N of A minus B union B minus A. Okay? N of A minus B union B minus A. This is A minus B, right? B minus A means how do you get? Let me draw B minus A also. B minus A means only I am drawing with the other color like orange. Otherwise, I will go with blue. You see, N of B is N of B minus A. Sorry, I am telling B minus A. This is my N of B minus A, right? N of B minus A is this. N of A minus B is this. If I make union, I am getting, if I make union, I am getting what? N of A delta B. Okay. So if I make union of these two, I am getting N of A delta B. Similarly, N of A, N of B, N of A union, B union C is equal to N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of A intersection C plus N of A intersection B intersection C. Okay, very good. Let me draw the Venn diagrams and I will explain the complements. Okay. You see, n of A complement. Let me draw that first. N of A complement union B complement. A complement means you take this is n of A complement I am drawing. N of A complement union B complement. No? Yes. Let us observe this one first. That is n of A complement union B complement. Okay. A and B I am drawing. Okay. Very good. This is A. This is A and this is B. Okay. What they asked here, A complement. A complement means what? This is my universal set. Whenever you draw a rectangle like this is going to be our universal set. That is very important. I forgot in last two figures. Okay. You try to make it right like universal set. Okay. Universal you have to write. N of A complement means what you do? What you are getting? A complement means from universal set, you have to remove only A set. The total A set you have to remove. The remaining total thing is going to be our this total thing except A set. Am I right? Except A set, the remaining total thing is going to be our, what do you say? A complement. This shaded portion is A complement. Am I right? A complement. You can write dot like this or A complement like this also. Okay. Very good. And now, next, in the same manner, I am going to write this is my A complement. A complement union B complement in the same way. Let me write the B complement. This is A and this is B. Okay. These are the two sets I am drawing. So you take this is my universal set. Okay. Very good. Now what I do is I am drawing B complement. How can I draw B complement? B complement means from universal set you have to remove B. Total B set you have to remove. So that means I can include all the up to like this. Yes or no? But I should not touch the B set. Am I right? Okay. So this is my B complement. Okay, this is my B complement. Actually, I have to take only B set, then you can easily understand because I took both, no? You both also. You assume that only B is present, A is absent like that. You understand? And if you union these two together, what do you get? If you union these two together, you are getting N of N of A complement union B complement, right? You are getting, if you add these two, you are getting N of A intersection B whole complement. Let me draw for this N of A intersection B whole complement. Whether we are getting the union or not, you see. This is N of A, N of B. A intersection B, it means this one, right? Complement means you should not take that, right? Okay. Complement means the remaining total thing except intersection. You understand? Whether we are getting the same thing, when we union these two, or not? Here this is absent. Here also this is absent. Here this side total thing is present. Here also this side. That means A intersection B complement is we are getting when you union these two, right? When you union these two. So you are getting the same. That is n of A complement union B complement is equal to n of A intersection B whole complement. Or that is equal to n of U minus n of A intersection B. From union, we removed A intersection B. That only we did. The same thing we did here. Okay. In the same manner, n of A complement intersection B complement is equal to n of A union B whole complement. That is equal to n of union minus n of union A union B. Okay. Very good. So in this manner, we can observe the Venn diagrams and types of sets. Okay. We observed all the things. In some cases, we can prove any kind of things through these Venn diagrams also. We can solve problems through Venn diagrams also. We have some kind of what I can say verbal problems. We have to prove, we have to solve the verbal problems in through Venn diagrams and by using like these elements in different sets, no cardinal number sets like these standard cardinal representation of elements. By using these also we can solve. Okay. Understand? Very good. Okay. Thank you. Please like, share, and subscribe.